Good morning everyone. This is Shilpa from CSC department. In this semester, I am going to teach the compiler design subject for the 3-1 students. The prerequisites of this subject is data structures, automata theory and computations. Data structure, the students can gain the knowledge in 2-1 semester only. Automata theory and computation, the students can gain the knowledge in 2-2 semester only. Designing of a compiler. First of all, what is the need of the compiler? Any high level language or machine understandable language can be converted into the machine understandable language, or either you are going to convert the machine level language or assembly level language code. While converting this process, many phases are involved. Lexical analyzer phase, syntax analysis phase, semantic analyzer phase, intermediate code generator, code optimizer and target code generator. Finally, we are going to generate the assembly language code. Symbol table as well as error handler is connected with all the phases of the compiler. And lexical analyzer, syntax analyzer, semantic analyzer is combinedly call it as a front end, and code optimizer, code generator, the back end of the compiler. The intermediate code act between these two ends, and symbol table can store the data, and error handler, whatever the errors can be generated by these phases, handled by the error handler. In the compiler design subject, we are going to learn these whole phases. We can divide it into the 5 units. Let us discuss with the course objectives as well as the course outcomes. We are already framed the each unit one objective as well as the outcome. The first unit is understand the process of language translations as well as the lexical analysis. And okay, first part of first unit, let us discuss what is the process, how you are going to convert, how many phases involved in this processing. We are going to discuss with the simple examples. And the second part of the first unit, we are going to in depth, we are going to discuss what happened in the lexical analysis phase. And after completing this first unit, the students can gain the knowledge of this, demonstrate the language translation process and the phases of the compilation, particularly in the lexical analysis phase. Okay, let us come to the second objective. Summarize the variety of parsing techniques. Means whatever the output generated by the lexical analysis phase, that goes to the syntax analysis phase, and they can form the hierarchical structure of this tokens, that is call it as parsing or parse tree. Divided into the 2 types of parsing techniques, top-down parsing as well as the bottom-up parsings. And in the second unit, we are going to discuss the top-down parsing as well as we are going to discuss the context-free grammar. Okay, after gaining the knowledge of the second unit, the students can understand what is mean by the context-free grammar as well as the top-down parsing techniques. Coming to the third unit, in third unit we already discussed the bottom-up parsing techniques as well as the semantic analysis phase. And after completing this, the students can gain the knowledge of different types of the bottom-up parsing techniques. These bottom-up parsing techniques can be divided into the SLR, CLR and LALR parsing techniques, as well as syntax directed translation schemas. How your SDTs, different types of the SDTs, how you are going to convert and how we are going to eliminate the errors. We are going to learn complete in this third unit. The semantic analyzer phase can be generated the final semantic tree that goes to the intermediate code. The intermediate, many intermediate forms are there, but most popular way is the 3 address code. We are going to generate the 3 address code using the 3 addresses. At max we are going to use the 3 addresses. As well as we are going in this unit, we are going to use the storage allocation strategies using the symbol table. The data can be stored into the symbol table. We are going to discuss the different types of allocation strategies: static allocation, stack allocation, as well as the heap allocation techniques. After completing this, the students can gain the knowledge of analyze the the data structures used for the symbol table, and the storage allocation strategies, and the forms of intermediate code, as well as the type checking. Also different types of type checkings are there. We are going to learn these different types of type checkings. This is covered in the 4th unit. The 5th unit, we are going to discuss the optimization techniques as well as the code generation. In optimization, we are going to optimize the code, whatever the code generated by the intermediate code, using the different types of the techniques. We are going to reduce the size of the code. Okay, after reducing the code, that code goes to the last phase, that is an code generation phase. Here we are going to generate the assembly level language code. Using the assemblers, we are going to write the assembly level language code. Whenever you are going to complete the assembly level language code, we are going to reach the 99.9% of the machine level language code. It is very easy to convert the assembly language to machine understandable language code, that is in zeros and ones. Finally, the error handler can handle all the errors produced by these phases. Lexical analyzer can generate the lexical errors, and the syntax analyzer can generate the syntactical errors. Semantic analyzer can generate the semantical errors. Like this, we are going to generate the n number of errors that can be handled by the error handler. After gaining this, completing the 5th unit, the students can gain the knowledge of machine independent code transformation techniques. Different types of transformation techniques are there. The students can gain the knowledge of translation forms, as well as the object code generation, and we are going to learn the acyclic graph register allocations. These up to the 5th unit, we are going to reach the final phase of the compiler. Finally, we are going to generate the assembly level language code. Coming to the textbooks, the prescribed book is the compiler's principal techniques tools. The author is J.D. Ullman. This is a prescribed book for this compiler design subject. And coming to the references, these are the references we are going to follow: compiler constructions, compiler design, engineering a compiler, principles of compiler design, implementation of the compilers. These are the references of this compiler design subjects. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.